All right, so when we left off last week, I think we just got to extrude cutting this. So I am planning to anyway go over like doing the second one, but do you want to see like before that, like, I guess extruding the first cut, or are you good with that?
Yeah, I'm good.
Okay, sure. So I'll get to that when we start. Are there any other questions from anyone? All right, so I did find out what this thing is called. So it's no longer a do nothing machine. Seems to be a device that is used to draw ellipses. So kind of makes sense. Hopefully seeing this like ellipse helps you visualize what this thing does. Essentially, each of these blocks can only move along their channel. And so as that happens, at one point, this block is kind of in the center. So you have the whole length of the stick being like the diameter, the major axis. When this one's in the center, you kind of have only a fraction of the length of the stick being the diameter for the minor axis. See if there's any animations of that. All right, it's probably very stuttery, but you can try looking it up yourself to see animation of what we're going to have at the end. But this is what it is. This is what it's for. It has a purpose now. All right, when we left off, I'll just undo the last bit of progress. So from what I'm gathering, everyone's here, right? Is anyone not at the point where they have a square block with this channel cut out? All right, great. Wait, I see a message. You weren't here last week. Well, what we did last week, if you watched the video, I'm not sure if those are posted, but essentially we put together our sprocket machine. So you might have to look into how to do that yourself. But we'll go into more assembly stuff at the end of making our ellipse channel. So you'll learn the skills regardless, I suppose. In terms of this, I think, all right, so someone has a question about the channel anyway, so I didn't mean to click that. I'll show it again. It's not too challenging. So hopefully this first, up to here, hopefully is straightforward enough since we've done a fair bit of extruding. Next thing you're gonna want is to draw a sketch. So in my case, I just sketched it on this front plane here. What you can also do is select the face you want to draw on and then create a sketch. But either way works.
Are you drawing on the right plane?
Yeah, so you want to draw on one of these thin faces. It doesn't really matter which one. So make sure your sketch looks something like this. I suppose the main important thing is to make sure that you have a line here between these points. It may be a bit hard to see because like the part is visible and there's a construction line. If I hide the part, you can see there's like a solid black line between those two highlighted points. And a quick way to tell is that, are you able to select this? And if so, there's a closed region. If you can't select and highlight this trapezoid, that means you don't have a closed region. So check that, make sure you have that. Otherwise, you want to have that sketch. I'll reveal my part again. So it seems like the question this person had was about extruding it. So it's not too different from what we've done before with extruding holes. you want the first setting to be solid, which it is by default. The second one should be remove, which is like cutting. The third one, you want to select that trapezoidal profile. Remember, if you couldn't select it in the sketch, you can't select it here. So make sure you actually close that profile. For the extent, it'll probably be blind by default. You can just change it to through all. Make sure the arrow is pointing the right way. So you don't want to cut outside. You want to cut through the material. You can also be like up to next. And for the merge scope, if this isn't by default part 1, just make it part 1. And hopefully it just works out for you. If it doesn't, please ask another question because there may be a few things that are going on. Namely, if the person who asked about not being able to get the trapezoid shape, if you could just let me know if you're good.
How do you make the trapezoid?
The sketch. Are you asking about the sketch?
Okay.
Or are you asking about the cut?
Just the sketch.
Okay, sure. So for here, there's a lot of ways you can go about it. The main thing you need is just these 4 lines to trace out this shape. And in terms of dimensioning, in this case, it kind of does matter for the dimensions because another part will depend on it. So you might get some interference later on if you don't like fully dimension it. But
Are you supposed to extrude square first and then do the?
could you repeat the question?
Are you supposed to extrude the square first and then do the trapezoid?
Your mic is cutting out, but I think you're asking about like this large square here. And yes, you do need to extrude this out first before you can extrude cut the trapezoid. I'm not sure if someone still has an issue with making the sketch. If so, say something and I can show it. If not, I'll move on. Can't get the lines black. Yeah, sure. I'll just go through this again. I did kind of rush during the last class. So I'll delete everything from my sketch. I have an empty sketch. Nothing is present. So the first thing I want is some kind of reference to attach my sketch to this part that already exists. So you'll notice that I can actually like hover over the edge of the part and it'll bring a point that I can click on, even though it's not like technically in my sketch. So you can take advantage of that. You can see I can even hover over the line and like the little midpoint box comes up. So if I click on that, it'll create that constraint. And so using my line tool, I can just follow along and kind of trace over the part boundaries that I see and make sure like I hover and snap to. And if I'm careful with hovering and snapping to, a lot of the constraints that I need to fully dimension and fully define the sketch will be made automatically. Like here you can see like there's a coincident, there's a midpoint. I guess that's for this point. For this, there is the constraints are present is my point. So hopefully just by drawing like this half of the trapezoid, you already have a lot of black lines. And if not, you can manually add in constraints using your coincident tool. And so the way I finished this out was to just make this midpoint line a construction line using my construction tool. I'll add my dimensions in. I forgot what they were, but it doesn't matter. And so hopefully just by having all your constraints set up, you can fully define everything, make it turn black. And as I've said before, if you ever have any like blue points that you can't figure out, just try clicking and dragging them and seeing how they move. And based on that, adding a constraint or dimension. And just to finish the other side of this trapezoid, I'll use my mirror tool, which I think I showed. First you select a mirror line, then you select entities to mirror. So I just click on the 3 lines that I want to mirror. And with that, I have my sketch. Okay, someone says it works, so hopefully that's taken care of. What I just realized is the trapezoid isn't supposed to go through the entire block, so I'll quickly go back and change that. Again, if you like hover until the constraints show up, you don't have to manually constrain everything, but you still can. Might be a bit large, actually. Sure, yeah. All right, I think I've made my channel a lot larger than it was before, but that is fine. Yeah, it's definitely larger. But we can always change that and go back to it, so. Just for aesthetic purposes, I'll so that's that. Hopefully we're all together now. So the next thing we want is to make another channel that's perpendicular going along the other way of, pardon? If you're unmuted, Stephen, would you mind muting yourself? Yeah, no problem. So we're trying to make the other channel, sorry. We're trying to make the other channel that goes across perpendicular. And so what we could do is go back and recreate that sketch on this face, on this face. But to do that, we'd need a lot of like going back, checking what the dimensions were. I was making things up as you saw. And so I'd have to go back and forth. An easier way and a way that'll update more easily, like I only have to change one sketch if I decide to change the side of the channel, is to use our patterns. So we've used the circular pattern before when we did our sprocket teeth and the pockets in the sprocket. And we're going to do it again, but in order to make this pattern, we need an axis. We need like the center of symmetry for where the circle part of the circular pattern is going to happen. And so one way to do that is to use a circle. And so a circle in 2D has associated with it one single unique axis, which is the one that goes through its center and is perpendicular to the plane of the circle. So what I'll do is I'll just create a sketch in the top plane. For me, that's the one that you're looking down onto, like the square of it. And so that's what you want, whichever face for you is that property. I'll make a circle with my circle tool, and I just want it to be somewhere in the center, right? And it really doesn't matter what the circle looks like. So the size doesn't really matter. All that matters is the location. And actually it could just be a point, as we saw last week. But what we're gonna do is we're gonna center the center of this circle onto the center of this square. And a way you can do that is by hovering over the edges of the part. So even though this block isn't actually part of our sketch, you can still hover over its edges and select points that are on the part, like I did there. So this is the midpoint of this vertical line. If I click on it, I can like select it as I would another point. Now I'll select the center of the circle, which is actually in my sketch. And with those two selected, I can just make them horizontal. Likewise, same with the vertical line, or the horizontal line. I can select these 2 points and make them vertical. And with that, you can see it turns black, everything's fully defined. So I have this circle now. And so with this, now I have what I need in order to fully define my circular pattern. So we'll open that up. Remember, it might be in a dropdown for you, like it is for me, where you have linear pattern, circular pattern. And what you want to do is change it from a part pattern to a feature pattern. Remember, a part is like the entire thing, the entire solid body you're working with. Feature is everything in your feature tree up here. So we want to pattern this feature, which was an extrude cut. So we change it to feature pattern. It asks you for a feature to pattern. So for me, that is this extrusion. So I click on extrude to. And secondly, we need an axis. So I click on the second box, which asks me for an axis. And for that, I can just click on this circle that I have. And you can see like Onshape has a preview, but it doesn't like it for some reason. In this case, it might be because I'm asking for 4 instances. Actually, that might have been correct. But the reason it doesn't like it is probably some kind of like geometric problem it has with calculating these like sharp corners. If I check on the apply per instance box down here, for me that resolves it, and you can see like the preview clears up. So with these settings, hopefully you're able to pattern this shape so you can get both of the channels. All right, hopefully we're good there. If you have any questions throughout, just put a message in the chat and I'll probably see it. And if I don't, just say something. Okay, can you go over that again? I assume you're talking about the circular pattern rather than the sketch of the circle. And I can go over both if needed. But if it's a pattern, you have your pattern tool option somewhere in the middle of your toolbar here. By default, it might have like the linear pattern as the icon, but if you go to the drop-down menu, you'll have circular pattern available. So for your options, you just want to set up something like this. First thing you want is a feature pattern and not a part pattern. What you want to select as your entity or feature to pattern is the extrude cut. So this thing is what you want to pattern. You want 2 of it. And if this axis of pattern, you want the circle that you drew on this like top down looking plane. So the circle here. can be your axis. And you do need to check this apply per instance box.
Okay. Sorry, Grace is late. Can you give her a short instruction how to get to this step?
We maybe help her later. Yeah.
Oh, okay. Thank you.
Yeah. Give us a little bit of time. We'll help her later.
All right. So for the student who asked about going over this again, let me know if you still have a question about this particular pattern. How to get the circle black? Good question. So the circle, as I said, it doesn't really matter if the circle is black as long as its center point is black. And the way you get the center point to be black is when you first draw a circle, you just have nothing, right? In fact, I'll delete the circle just to make that point. There you go. So I draw a circle somewhere vaguely in the middle, and all I care about is that the center of that circle is in the right place. So what you want is to define it relative to this part that you already have, which is this square block. And you know where the center of the square is, right? So one handy thing that you can do is, without bringing it into the sketch, you can just hover your mouse over the edges of the block. And when you do, you'll see the points come up. So if you can do that, just click on this. And then you can use your normal constraints. So horizontal constraint. Likewise, for the vertical constraint, I can just kind of hover over the right place and this point comes up. And I can add my vertical constraint. So with that, you can see the center of the circle turn black, and that's all I need. I don't care about the diameter of the circle, since it's just for a reference. Hopefully, a person who asked, you're able to get the center black there. So like always, just ask again if you have another question. But I'll go back. Whenever you change something like that, Onshape doesn't always recognize what you asked it to do before. So I'll just update that and we'll have our channel. So with that, that's the conclusion of the first part of 4 of our ellipse trammel. We'll leave this for now. We'll put it aside for the time being and come back to it for assembly. So if you're just joining us, you can start with the next parts that we're going to go over. They're pretty much independent except for the slider, which will have the same dimensions, but you can always make the trammel based on the slider, or the base made based on the slider. So no problem there. All right, so I'll move on. I don't see any questions. Next part we're going to make is this trapezoid shape here in the middle. What we want is the extruded trapezoid shape and the pin on top. We'll just combine that into one part, since that's probably one way that this thing could be made. We don't really need the added complexity of making the pin a separate part, so we'll put them together. So before I go in, I already know the first thing I'm going to have to do, which is get a trapezoid. And I also know the size of the trapezoid is going to be dependent on the size of this groove. What I can do is use my measure tool. Let's say someone just gave me this STL file and I don't have access to like these sketches. Even then, I can still know the dimensions of this trapezoid because I have my tape measure here. So I can select this line. That tells me, oh, it's 0.6 inches. Let me measure another thing. trying to clear my selection. Measure the distance between this point and this point. That's like the top base of the trapezoid. That's 0.3 inches. Okay. And what's the height of the trapezoid? You can see along the z-axis, it's 0.175. And so with that, 0.3, 0.6, 0.175, that's everything I need to know about the trapezoid. So I go over to my next part studio. This one's for the slider. And I'll just start off with my sketch. So it's pretty straightforward. Feel free to go ahead if you know what you're doing. You create your sketch in one of the planes. Whoops. And like we did for the groove, you can just sketch a trapezoid. Doesn't matter too much where it is. I'll just put it so that a corner is on the origin. And as we've done several times, just add your constraints. So I'll make these legs equal to each other. Now that I did that, you can see that they always stay equal. I need to apply the heights. So this was 0.175. This was 0.6. And this was 0.3, I believe. Hopefully that's correct. If not, we can always go back and fix this. And so there you have it, fully dimensioned trapezoid. Since we already did one of these before, hopefully that was not too bad. I'll accept my sketch. And there we go. Next thing to do, we need to make it 3D. Use the extrude tool. And same as we've always done, and just extrude it. How deep should I extrude it? Well, just based on what looks reasonable, maybe somewhere between like a 1/2 inch and an inch. The dimensions, you should do it based on whatever your trapezoid was dimensioned to. So it may have been different for what you did. What I did was I went back and I used my tape measure to measure the base of the trapezoid, which for me was apparently, but for me that was 0.6 inches. Then 0.3 inches and 0.175 inches for the height. So just go back to your base. You can just look at the sketch too and find what the dimensions were and make it the same. In real life, if you're trying to manufacture this, depending on the manufacturing process, you probably make the dimensions either nominally or as modeled, a bit smaller or larger. And it depends a lot on like what the process is, so, and what the fit is, right? I might get into that if we talk about 3D printing at the end of the class, but for now, we just want everything to be nominally exactly touching each other. So like a perfect clearance, right? So with this, now all I need to do is make the pin on the top that the link will go through, or that will go through the link. So it's just a simple cylinder. So we're going to use the same idea that we did before when we were making the axis circle for the circular pattern just before. We're going to make another circle sketch on top of this trapezoid prism. So create a sketch. Like I said, you can create sketches on faces of objects. So you can see that this sketch plane is actually not, it's not touching the top plane. It's actually on this top face, this one. So with this sketch made, How do you find the height of the trapezoid? So again, like I'm showing you this measuring tool just to show you that the measuring tool exists, but if it's being difficult, just go back and look at your sketch. And it's possible that you dimension this trapezoid not based on the height. Like I guess in my case, I also didn't do it that way. So you can try to make your trapezoid the same way using the dimensions that you do know. Or if you're having trouble, just do it based on this point at the corner and the base. And you can see Onshape tells you which direction the distance is as well. So looking at this, I can tell that in the Z direction, which is the vertical or the height distance, it's 0.175. I didn't need to do that in the sketch either. I could just measure from here to here. And for me, you can see Z direction, 0.175. That's my Z direction. And actually, it turns out you don't actually need to have them match perfectly. Onshape can still handle the mate, but for aesthetic purposes, we don't want any interferences or large clearances. So we'll just try to make it correct. But yeah, it's not the end of the world if you can't. So as I was saying, make a circle on top of your trapezoid. You start off by just drawing it, give it a size, a diameter. And by doing the same trick where you can hover over edges of a part from a sketch, you can assign a relation using a vertical and a horizontal relation. So with that, that's fully defined because a circle is fully defined by its position and its size. Okay, hope that's good.
Wait, how to do the circle?
So from here, what we're gonna do is extrude the pin out. Good question. How did I? Well, as we did for the, what do you call it? The axis of revolution. You can draw the circle wherever you want, but the key idea here is just to take advantage of these handles that Onshape gives you. If you hover over the edge of a part, kind of near its center, it'll understand that you want its midpoint and it'll offer you the midpoint like that. So as a zoomed in demonstration, you can see as I hover over things, they kind of highlight. So if I hover over this line, you can see in the middle, there's that black point there. And so if I bring my cursor to that black point, just the point will be highlighted. So I can click that. I can click the center of the circle. And with those two things selected and just those two things selected, I can give it a relation. So I make them vertical. Likewise here, I can select the midpoint, select the point, and make them horizontal. You can see the center of the circle turn black. And that's a sign that it's correct. Diameter is whatever you want. And as I was saying, extrude it. Height can be whatever looks reasonable to you, maybe like a ½ inch. And that concludes the creation of the slider. You'll notice that there are two of them, but they are identical in form and function. So we'll just put in two of these when the time comes. So that's 2 out of 4 completed. We just have 2 more to go. We might get to the assembly this class actually, which was pretty good. So when I talk about the linkage, I was talking about this bar that has the 2 holes in it for the pins to go through. And this is a pretty straightforward shape, right? It's essentially just a long rectangle. And that's what I'll make it. And the age-old question, how big do I make it? The answer can only come to me through looking at the base, since that's the part that I have. If you don't have the base, just make it up and make the base based on how long your linkage is, or just change the linkage after you make the base. But the total length of this square is 2 inches. And so in principle, the distance between the holes probably should not exceed the distance between the center of the square and the distance somewhere around the end of the square. So that's from here to here is like an inch. From here to less than here is less than an inch. So the distance between the holes should be maybe 3/4. And then how long is the bar extending past that? Not too far. So I'd say just thinking about that, it's reasonable to make this thing perhaps an inch long. And if I turn out to be wrong, well, I can just change it again. In fact, I think I do want it a bit longer, just so there's plenty of space for the handle. Maybe 1.5 inches. The thickness, I do know that this thing has to contain a pin that's 1/4 inch in diameter, since that's what I just made in the slider. This is 1/4 inch in diameter. So it does need to be thicker than that. And I do want like a minimum wall thickness. If I just make this 0.26 inches, then the wall thickness is going to be 0.005 inches on either side. And that means it's like really easy to break. You can see here in this demonstration, like the wall thickness is really thin. So the pin is pretty much cutting the linkage in half, and that's not great. So I'll make it a bit more roomy, I guess. You can see it doesn't look very thin now, but not much you can do about that. Next part of the linkage is adding the holes. As I was saying earlier, just based on the size that I made my parts, it makes sense for this to be about 3/4 of an inch apart. For you, it may vary depending on how big you made yours. So it's up to you to decide based on that. And I'll start adding constraints as I usually do. I know these circles need to be equal, so I'll give them the equal constraint. I want these 2 circles to be in line. So like, I don't want one of them to be higher than the other. I want them to be horizontal. So again, I can add a constraint for that. And I need to set a size for these circles. I know that has to be 1/4 inch so that it matches the pins on my sliders. And it's still not black. What am I missing? If I drag around my blue things, I can see, oh, the location's not determined. So let's think about this. I want one of the holes to be close to the end, right? And I want one of the holes to be like farther in. So I'll add a dimension, just telling Onshape how far from the end of the linkage the circle should be. And 0.2 seems good to me. And what's left is how high should this be? So you can take one of the blue points, and if you drag it, you can see it still moves up and down. So I need one more dimension. Now I could dimension this with a number, but in terms of what's best practice, my design intent here is for these circles to be in the center symmetrically along this like horizontal axis. And so I'll use a relation instead of a dimension here. And I can do I can do essentially the same trick as I was doing before, where I get the midpoint of this vertical line and I make it horizontal to this point. but I can't just grab the midpoint here, unfortunately, so I'll have to explicitly make the midpoint. So I have my point here. This is my point tool. I can plot my point along this line. And you can see, as if I hover in the right place, Onshape will guess that I'm trying to make a midpoint, and it'll pull up this like little box that you see just around my cursor. You can see no box, box, and that just means it recognizes I want a midpoint. I click on the midpoint, and it's black because it already knows that it's a midpoint. So with this point created, all I have left to do is make these 2 points horizontal, which I can do again with the horizontal constraint, and fully defined. So I'll pause for a moment there just to check for questions. But once you're at this point, you just extrude it, and if you want, you can fill it the corners so it looks around like the picture. Now, the observant among you may have realized something, which is that how are we going to attach the handle, right? Maybe a bit too short for that. So you're right if you were thinking that. Good on you. I'll make this longer. And we may or may not end up needing another reference point here just to attach the handle. What I'm thinking is if I just fill it the ends of this, Onshape will automatically interpret a mate connector in the center.
Do that
here.
again?
Are you asking about the fillet
Okay.
around the corners? If you are, there's a tool called fillet. Looks like that. And you can just pick edges. So you can see I'm clicking on the edge here.
Oh,
on that
okay,
line.
cool.
And when you do that, Onshape just rounds the corner off for you.
Oh, that's so cool.
Yeah. You can actually do it to a lot more, like it's a pretty powerful tool. Like if I click on this face, it'll round everything off. Let me just measure this to make sure. Okay. So in my case, I kind of want the fillet. I kind of want this link to terminate in an actual circle, which right now it doesn't, just because the fillet radius is a bit larger than, it's a bit larger than half the thickness. So in my case, if I make it 3/16, it'll become a perfect circle. And I got that number just by dividing this distance by 2. So from here to here is 3/8 of an inch. So half of that is 3/16 of an inch. So I just type that in and it becomes a circle. And that's not too important. Like it'll probably still work no matter what you do. But that's that. You have your linkage. Our work here is done. And the last thing that we're going to make is the handle. So that's this knob at the end here. And what I'm considering is maybe we can just reuse the handle from our Sprocket machine, and we can see how we can import parts from another assembly or another document into our current document. But I'm guessing that for many of you, the handle might not actually fit because it wasn't designed for the same part. So yeah, we'll just make a new handle. That's fine. But the process is the same as before. We're just going to use the revolve tool to create this. since it is rotationally symmetric. And I think you all know how to do that at this point, so I'll let you to it. In the meantime, I'll just make my own as well. So remember to make your line of, make sure to have a vertical line, just so you have that axis to revolve about. And as long as you have that, you can do whatever you want. I'll keep mine pretty simple. And how big should this thing be? Well, I do want it to fit nicely onto the end of my link. And from what I remember, this was 3/8 inch in diameter. So I'll just make it the same as that. So for the diameter to be 3/8, this needs to be 3/16 in radius. Again, your parts may vary. I don't know how big you've been making your things, but so that warped everything up, but I can use my constraints. So I'll make these two highlighted lines equal. And I'll bring this out a bit. What I can clearly see is that it's too tall, so we will make it half as tall. This curvature, I don't know. That looks decent, so I'll dimension it. Maybe even something like that. And if you want to get fancy, add all kinds of whatever you want here, and it'll make the rotated pattern look like that. I just kept it very straightforward. But with something like that, you have your profile, and we've all used the revolve tool now, both for the handle on the other assembly we did. So I think you know how to use it. You get something that looks like the cooling stack of a nuclear power plant. So that's that. I do want to round these corners off just for safety. These look sharp enough to cut the person who's using it. So I can just add a fillet like that. I guess Onshape is not a fan of that particular fillet. I wonder, it's too sharp. Yeah, it's too large. So I guess I don't really need that one. That's fine, right? Sure. So there's my handle. Looks like the top of a push pin. And there we go. With that, we have all our parts. I'll pause here and take questions about any of the parts. And I suppose for the student who joined later, I can go through this again, but for the rest of you, I'd say use what you know about assemblies to try to assemble this thing. I'll say that you do need to use a tool that we have not used before, which is called the slider mate. So let's see. We do also only have 10 minutes left in the class. So for those of you who are at this point, either ask a question right now or begin working on the assembly. There are some things that you can do already, such as fastening the base to the origin, which we talked about before, why you want to do that. And you can start to mate the linkage to the sliders. And hopefully that will keep you busy for some time as I go back and explain the base. And so I guess before I go through this whole thing, do you want the demonstration of the base? Student who joined us a bit later. not, I might just go over the assembly as a group, whichever seems more useful. All right, well, if you do later, just ask. I guess if the class ends, you can always go back and look at this week's or the previous week's classes. So here we are. We're in our assembly. Brand new, nothing in it. We need to insert our parts. So for our part count, we need 1 of the base. We need 1 of the handle. We need 1 of the linkage. And we need 2 of the sliders, not 1, but 2. And with that, you can just click the green check mark. I get the second trapezoid cut out again for the base, sure. So when we're here, I guess I'll roll it back. Since you're asking for the second, I'm guessing you have this one. So what we're trying to do is to avoid redoing the sketch for the first one by using a pattern instead of like recreating the sketch on another face. And so it's a circular pattern that we're trying to do. And as you recall, the circular pattern needs an axis of pattern. And as we found out last week, you can't just pick like the square face and call that the axis. It needs to be like a point or a circle. Or an actual axis, but you know. So the way that we create that axis is through the sketch. And what I do is I create a circle. The size of the circle doesn't matter. From what I remember, it can actually just be the point. So you're free to use the point tool as well, I believe. And the important thing is to make sure the center of the circle is aligned with this midpoint and with this midpoint. So if you're really good, you can just like do that. And it's done, right? The center is black. If that's too finicky, which understandably, maybe, just draw the circle anywhere. It can be out here. And kind of bring it somewhat into place. If you hover over these lines, you'll see these midpoint markers come up. So you can click on those, even though the part technically isn't in your sketch, right? Like that's not in my sketch, but I can still click on it. So I click on this, I click on this, and I make them horizontal. I do the same thing. I click on this, I click on this, and I make them vertical. And now the center is black. That's all I care about. The circle doesn't matter at all. Hopefully that's straightforward. Next thing, you have to make your circular pattern, which again is potentially hidden under your linear pattern. It's in the same drop-down menu. Make sure to change it from a part pattern to a feature pattern. That's just the difference between like selecting one of these like solid objects or selecting one of these like steps, right? So that's the feature you select. For the feature, you pick extrude from your feature tree. Then you move on to the axis of pattern. You have to click this box. And for that, you want to click that circle that you drew. Leave the angle at 360, leave the instance count at 4. That's just what will work. And you have to apply per instance. By default, that will not be checked, but you do need to check that box. And leave equal spacing on as well. And with that, hopefully it just resolves and you get your second cut. If not, let me know. All right. So I imagine some of you have done this already. We're just going to fasten the corner of the base to the origin. And again, the reason we're doing this is just so that the center of the assembly is in some logical place with respect to everything that's in the assembly. In my opinion, actually, the center of this base is actually a more reasonable place to put the center. So I'll just do that. But at the end of the day, it doesn't really matter, right? I just want it to be grounded. So that's my first mate, the fasten. Now I can't move the base anymore. Like I can move these parts. They follow my mouse. But the base no longer moves. And that's what I want. And this is where we might get into something new. We have this mate that I hinted at, which is called the slider mate. And I guess this will be the last thing that I introduce. And at the start of next class, we can go over it again if people have questions. But the slider mate does exactly what you imagine it. Like if you know what like drawer slides are, right? It's like whenever you open like a drawer in a piece of furniture, it has these things in them, and that allows it to slide in and out, right? It's like a linear type of bearing of sorts. And so that's what function the slider mate is kind of emulating. Whenever you have something that's slipping within another shape, that's when you use a slider. It's like a piston in a cylinder, right? What else? Like a valve, maybe in an engine block or in a pump, something like that. You'd want a slider. So you open up the slider, it brings up this window. Same as the other mates we've been doing. You need mate connectors. And how do we do that? All right, so what you're going to select is the face along which the sliding action is happening, right? I believe I can select this face, and I haven't done this in a bit, so if I get it wrong the first time, we'll learn as we go. But I believe you select the face as well as the axis. So, okay, that's pretty close. What you're going to want is to make your mate connector line up with like the direction, right? And this will make more sense as I actually show it properly, but I start off by picking the face that's perpendicular to the direction of motion. I move the mate connector over to wherever the line that I'm going to pick is going to be. I'll demonstrate this again, so don't worry too much, but just follow along what I'm doing. So I pick that point. You can see the mate connector like right there. And for the other mate connector, this is what the thing is sliding inside of. I'm going to pick this line, and you're gonna have to do some like camera turning and such. Whoops. But if I pick this point at the end of this line, you can see the line is highlighted and this point is highlighted. And hopefully this works and I correctly remembered how to do this. If not, we'll probably have to do it next class, but I have hope. And it looks right to me. Let's see if it behaves the way we expect. And it slides. We did it. All right, so that was pretty complicated. I'll definitely show that again, but to explain more of what this mate does in words and with a visual aid, it only can move as you would expect if this thing were actually in the groove, right? It only moves along that line and the direction of motion is perpendicular to that first face that I selected. So that's the slider. In terms of recordings, I'm not like the host of this meeting, so that's up to, let me see, but yeah.
How do you add like color to it?
If you're talking about the parts, you have to select the appearance in each of the part studios. So for the base, if I want to color the base, I go in here, I right click the part, edit appearance, that's the fourth option from the top,
Okay.
and I can change it to whatever I want. And if you go back to the assembly, it'll update there. All right, so we're past time. I guess I'll leave you with either the option to try to finish this yourself, which would be very impressive, or whatever. I'll see you again next week for last class, 7:15, same as usual. And if we have time at the end, I'll go over a bit of 3D printing related stuff, but it seems like this class, the CAD ended up being the main focus, which is fine. So that's all I've got. See you later.
Bye. Can you post
Goodbye.
that in the classroom?
Yeah, Miss Hugh,